Hello everyone, welcome to 1045 Engineering. We are here with yet another video in our Grind 75, a Better Blind 75 coding series. So today's problem is on finding the lowest common ancestor of a binary tree. It is a very frequently asked interview question. Let's go through this, understand it and start solving. Okay, last time we have solved the merge intervals. You can find it in the list. Let's start with lowest common ancestor of a binary tree. Okay. Given a binary tree, find the lowest common ancestor, LCA, of two given nodes in the tree. According to the definition on Wikipedia, the lowest common ancestor is defined between two nodes P and Q as the lowest node T that has both P and Q as the descendants. Okay. So I'm very sure most of you are already aware what is called the lowest common ancestor, but let's understand this from the example. Okay. So we can see in this case we are given P is 5, Q is 1, lowest common ancestor. That would be the node that contains both of these child nodes. Okay, so that is 3. 3 contains 5, 3 contains 1. Similarly, if we go to this example, P is 5, Q is 4. Okay, now for this one, 5 already contains 4, right? So 5 is the lowest common ancestor, right? Because a node is also an ancestor of itself as well, right? So in this case, we'll return 5 as the lowest common ancestor. Now, how are we going to solve this problem, right? Please take a minute, think of a solution or approach, and let's start. Ready? Okay. So let's say what we can do is, it's simple, right? We check for the base condition if the provided root is null or is equal to P or Q, right? If it is equal to P or it is equal to Q, that means that this is the solution, or it is null, then this is the solution because there is no solution. Otherwise, we'll check for lowest common ancestor on the left subtree, or we'll check for the lowest common ancestor on the right subtree. In case we find a lowest common ancestor on the left side also and the right side also, like in this example, on left side we'll get 5, from right side we'll get 1, then root is the lowest common ancestor. Otherwise, if only one of the left subtree or the right subtree contains both of the ancestors, that is the ancestor, right? So we'll check recursively, we'll check for the null, then we'll check for the LCA on the left and the right side. Let's say we check for 5, okay? We'll recursively call the LCA for 6, and similarly for 6 left child, that is null, right child, that is null. Okay, so we can return null from this point. For 5 but from 5 alone, since 5 is equal to P here, 5 will be returned from the left side LCA for row 3. And when we go for the right one, we'll check for recursively since it is not equal to P, Q or null. We'll check for the left child, that is 0. We'll check for the left child of 0, that is null. Right child of 0, that is null. We'll return null from here. Similarly, we can return null for 8, and both of them will return null to 1. So on 3, right side LCA will be null, left side LCA will be 5. Since only one of them has the values, that would be the answer. So 5 is the answer. Okay. Let's start coding. It's a really simple problem. Once we code, you'll really understand it well enough. Okay. So we'll check for the base case. So we'll say base case, that is if the root is null or equal to either P or Q, it is the LCA, right? So we'll check if root is equal to null or root is equal to P or root is equal to Q, right? Then we'll say return root. Okay. Now we'll search recursively. We'll call the same method, lowest common ancestor, for the left hand side of subtree and the right hand side subtree. Okay, so we'll say recursively search for all LCA in the left and right subtrees. So we can say tree node left LCA is equal to lowest common ancestor, and we'll pass root root dot left, P and Q, right? Similarly, we'll check in the right side subtree. So we'll call it right LCA is equal to lowest common ancestor. We'll pass root dot right, P and Q. Okay, so for this case 3 was the root, it is not null, it is not equal to P, it is not equal to Q. So this code does not enter this loop. So we check for the left LC on the left side. We call the same method again. We pass root dot left, that is 5. Similarly, we call on the right side root dot left, that is 1. From 5, when root dot left is called, we match root is equal to null. No, root is equal to P. Yes, right? P is equal to 5 here. So this one will return 5. You can say it returns 5. On the right hand side, we call the right LCA. It calls this method for 1. Then it is not null, it is not P, it is not equal to Q. We call recursively for the left subchild and the right subchild. For 0, again we call for the left subchild, that will be null, so it returns null. We call for the right subchild, that is also null. Okay, so we need one mechanism so that we know that from the right side we can return null. So how will we do that? If both left and right subtrees have LCA, that means they are not null. So the root is the LCA, as is the case for this one. From left hand side we'll get 5, from right hand side we'll get 1, so 3 is the LCA. So we'll say check if left LCA is not equal to null and right LCA is not equal to null, we'll say return root, right? Otherwise, if either of them is null, right, if only one subtree has LCA, that means the other one is null, return that LCA. So we can say return, we'll check left LCA is not equal to null. If that is true, we'll return left LCA, otherwise we'll return right LCA. That's it, right? Now let's see what happens. So when we call for the right LCA on this one, we call the left LCA and right LCA recursively for 0 and 8. For 0, again we call the left LCA, so that is null. We get null on this left LCA for 0. On right LCA also we get null for 0. So we check if left is not equal to null, right not equal to null. No, right? Both of them are null. So null will be returned for 0, right? Now, since left LCA and right LCA, both of them are null, the initial answer null remains the same. Similarly, for 8 also will receive null, and both 0 and 8 will be null for 1, right? So for 1, left LCA is null, right LCA is null. So this loop does not enter this part. We check if left LCA is not equal to null, we return left LCA, otherwise right LCA. Both of them are null, so we will return null from 1 also. Now at the parent 3, on the left LCA we had found 5, on the right LCA we found null, right, for 1, right? So if left LCA is not equal to null, that is true, and right LCA is not equal to null. So this is not true, right? Because right LCA is null. So loop does not enter this part. Then we return either of the LCA that is not null. So left LCA not equal to null? Yes. So we return left LCA, that is 5. So 5 would be the answer for this one. Let's run it. Okay, let's submit. Great. Okay, beats 97.17. Great. Overall time complexity of the solution, as everyone can guess, would be O of n, where n is the number of nodes in the tree. So that's all from today's video, everyone. For anything, please let me know in the comment section. In the end, please like, share and subscribe. Thank you.